Good afternoon to everyone. We have seen what is an algorithm, flowchart, pseudocode, and how do we convert from pseudocode to flowchart and then to algorithm. We have explored some examples in the last session, finding the minimum, right, maximum, checking the given integer is add or even. Hope we have gone through that. First, right, if you have any queries, you can ask. Have any doubts in the last session? Okay. In this session, now first we focus on solving the quadratic equation. Please take the notes. We are focusing on finding a solution to the quadratic equation. What is the general form of a quadratic equation? What is the general form of a quadratic equation? It is
ax square
ax
plus
square,
bx plus c equals 0.
yeah, plus c is equal to 0. This is the general form of a quadratic equation where a, b, c, these are coefficients called real numbers. Since this is a polynomial of degree 2, x square, suppose if it is p of x is equal to ax square plus bx plus c. Clearly, p of x is a polynomial of x and the highest power of x is 2, right? So this is a quadratic polynomial. We need to find a solution to this quadratic polynomial. That's what we have, the equation, quadratic equation. Ax square plus bx plus c is equal to 0. To find out the solution to this equation, first we need to find out the value of discriminant. Discriminant, this is a variable d which is computed as p square minus 4ac based on the coefficients, right? A, B, C. These are real numbers, are called coefficients of the unique polynomial. Having these coefficients A, B, C, first we need to evaluate a value d. D is said to be the discriminant. D is evaluated as b square minus 4ac. Once we evaluate the value of d, based on the value of d, what we can find? We can find the nature of roots. We can find the nature of roots. Suppose when b is equal to 0, b is equal to b square minus 4ac, this is equal to 0, we have roots are equal as well as these are real roots. Two roots, since this is a quadratic equation x square, we need to find the roots. The solution are the zeros of this quadratic polynomial. ZEROES. Zeros of this quadratic polynomial are two real numbers which are assumed to be x1, x2. When d is equal to b square minus 4ac is 0, we have the equal, right, as well as the real roots, the real and equal roots. When d is equal to b square minus 4ac, is greater than 0, d is equal to d square minus 4ac. This is greater than 0. In this case, the roots are real and what is its nature? Distinct are two different real roots when the condition b square minus 4ac is greater than 0. When d is equal to b square minus 4ac is less than 0, the nature of the root is imaginary. Imaginary roots, say x1 and x2. So to find out the value of d, we need to evaluate what is called b square minus 4ac. After the evaluation of b square minus 4ac, we can apply that result in the actual quadratic formula, which is given by x is equal to minus b plus or minus square root of b square minus 4ac, where b square minus 4ac, this is substituted by a variable d. So this is further equal to minus b plus or minus square root of d by 2a, where d is equal to b square minus 4ac. When d is greater than 0, we have a positive real number, square root can be taken, then we can evaluate two roots when d is greater than 0, x is equal to minus b plus square root of d by 2a. So call this as x1, and x2 is equal to minus b minus square root of d by 2a. This is the second real root. So roots are real and distinct in this category. Roots are real and distinct. Two different real roots when d is greater than 0. In case when d is equal to 0, when d is equal to 0, x becomes minus b plus or minus square root of d, that is 0 by 2a. Ultimately we have minus b by 2a minus b by 2a comma minus b by 2a. In this case, the roots are real and equal. Roots are real and equal. When d is less than 0, what happens? X is equal to minus b plus or minus square root of d, since d is less than 0, right? So in that case, here this is a negative quantity. This is a negative quantity divided by 2a, since square root of minus 1, this is equal to I. We have minus b plus or minus square root of, this is a negative quantity. We can write this is something into positive quantity into minus 1, so that this forms the negative root, right? So how do we obtain the negative root? Minus b plus or minus square root of minus b. Actually here this is b, right? Since this is a negative quantity divided by 2a, we have minus b by 2a. This is the real part. And since d is a negative quantity, evaluating the square root of d, right? We need to evaluate the square root of minus d by 2a. Since d is a negative quantity here, minus b, right? This can be taken as a positive one. Then this is the imaginary part. Imaginary part, this would be multiplied by I, right? That means I is equal to where I is equal to square root of minus 1. So what we have to find, we need to find the roots x1 and x2 of the quadratic equation. Find right whether x1 and x2 are equal. Here x1 is equal to minus b by 2a, x2 is also minus b by 2a for real and equal roots. X1 is equal to minus b plus square root of d by 2a, and x2 is equal to minus b minus square root of d by 2a when d is greater than 0. When d is less than 0, you can write the real part and imaginary part separately, and then you can conclude real part plus I into imaginary part. This is one root, you can say x1. And x2 is also obtained as x2 is equal to real part minus I into imaginary part. This is a way to solve the given quadratic equation. Now let us formulate the algorithm, right? A flow chart to solve this quadratic equation. First, in case of the flow chart, start. What are our inputs? A, B, C. These are the inputs. How do we represent input symbol? Parallelogram. Input A, B, C. This is the arrow mark. After inputting the three real numbers, say A, B, C, we need to find the discriminant value first. B is equal to B square minus 4AC. So we are computing here the computational statement, say D is equal to B square minus 4AC. Understand? Computational statement. Then check a value of D. Check if D is greater than 0. Or simply you can put a value D. Three possibilities we can write. Suppose if D is equal to 0, D question mark. Here I am writing if D is equal to 0. If D is equal to 0, what we have to find? We need to find x1 is equal to minus b by 2a, x2 is equal to minus b by 2a, and you need to give the message roots are real and equal. So in this case, here when d is equal to 0, I write the computation shortly. X1 is equal to x2 is equal to minus b by 2a. If you want, you can add a message. The roots are here, real and equal. This is the flow when d is equal to 0. Here I write when d is less than 0, and one more flow here when d is greater than 0, or write as it is d less than 0 and d is greater than 0. First, when d is greater than 0, we have the two roots. X is equal to x1 is equal to minus b plus square root of b by 2a, and x2 is equal to minus b minus square root of d by 2a. Roots are real and distinct. two distinct real roots that can be returned here. How to write? X1 is equal to minus b plus square root of b. This would be the numerator. This is entirely divided by 2a. So I write here minus b plus square root of b by 2a. And x2 is equal to minus b minus square root of b by 2a. These are the computational statements. I have written the computational statements in the single rectangular box. This is the flow when d is greater than 0. When d is less than 0, we can find the real part. For example, I write the real part. What is the real part? Real part is this one, minus b by 2a. This is the real part. Separately, we are trying to evaluate. Or you can write minus b by 2a plus I into square root of minus b by 2a, right? No problem. That is also a correct one. That is x1. Then you can write x2 is equal to minus b by 2a minus I into square root of minus d by 2a. So whatever is, or I write separately, real part is equal to minus b divided by 2a. And imaginary part is equal to, what is the imaginary part? Since d has already been a negative quantity, d is less than 0. Suppose minus 25. Minus 25 means square root of minus 25 can be written as 25 into minus 1, right? So that the square root is taken as 5 into square root of minus 1. We have the quantity 5i, where I is equal to square root of minus 1. So how to bring square root of 25? Already d is minus 25. That should be multiplied by minus 1. So we can write as a d into minus 1, or simply write minus d. Minus d means the value of d is negated, d is multiplied by minus 1 and divided by the equivalent denominator 2a. Since the denominator 2a is common for the entire numerator. So minus b plus square root of d by 2a, then minus b minus square root of d by 2a, where d is a negative quantity. So we are separating the real part and imaginary part. For example, here the imaginary part is square root of, what is d? D is already a negative quantity. So we need to write as square root of minus d by 2a. Minus d, this is entirely divided by the quantity 2d. Since this is the imaginary part, this alone imaginary part, since this is being multiplied by I. So after this we can write, if possible, x1 is equal to real part plus I into imaginary part, then x2 is equal to real part minus I into imaginary part, where I is square root of minus 1. Try to put these executable statements as in the rectangle. Here I is square root of minus 1. This is the flow when d is less than 0. So logically here the roots are real and equal. Here the roots are real and distinct. Here the roots are imaginary. Assuming that the computations are carried out here, then the next step, what we have to do, we need to print the values of variables x1 and x2. So here, right, we need to combine, right, all these things here. For example, here I write print x1 and x2. Print x1 and x2 after this computation. So here we can directly write this flow mark. Here also this one. After printing imaginary roots, in case we need to print x1 and x2. Then what we have to do, finally we need to stop. Here I write stop. Or we can draw one continuation symbol. For example, how do we specify the continuation symbol? For example, here I write because of space, I write something A in a circle. Flow is given to A. So in the next page, we can write starting from the flow A, our print x1, x2 can be put in the box A. Then here I write stop. This will be returning the vowel symbol. That's all. This is the flow chart to solve the quadratic equation. Figure flow chart to solve the given quadratic equation. Understand? Understand or not? Have any queries? Have any doubts?
No, sir.
Okay. We have drawn the flow chart right from the basic formulation. If you want, you can draw the English-like statements as the part of pseudocode. Input the numbers, input three numbers, find the discriminant, check if D is 0 and print the equal roots. Check if D is greater than 0 and if so print, compute and print the distinct real roots. Check if D is less than 0. If it's so, right, print the real part as well as imaginary part. That's all. This is the simplest pseudocode. Once this flowchart is completed, we can write the algorithm. We have solved several problems. So algorithm can be written using the steps. Step 1 say start. Step 2 input the variables are input numbers, real numbers, coefficients A, B, C. These are the coefficients of the polynomial P of x is equal to 0. Step 3 find the discriminant. Discriminant, this is stored in a variable D. D is equal to B square minus 4AC. Step 4 check if D is equal to 0. If D is equal to 0, then What we have to do, we need to find the quantities x1 and x2. So x1 is equal to minus b by 2a, x2 is equal to minus b by 2a. In the same step, step 4, right, we can write the part of, right, else part of if. So in the next page, I write if d is equal to 0, then real and equal roots are obtained. Else, else, that means in the same step, else, if d is greater than 0, then if d is greater than 0, then what happens? We need to find the real and distinct roots. In this case, x1 is equal to minus b plus square root b by 2a. I write x1 is equal to minus b plus square root of b whole divided by 2a. x2 is equal to minus b minus square root of b whole divided by 2a. Else, that means ultimately here when d is equal to 0 fails, d greater than 0 fails, that means here logically comment, right? For example, here d is what happens? D is less than 0, not equal to 0. D is equal to 0 fails, d greater than 0 fails, ultimately d is less than 0. So we can find the real part is equal to minus b divided by 2a, and imaginary part is equal to square root, right? We can use square root of minus b divided by 2a. Then we have x1 is equal to real part plus I into imaginary part. X2 is equal to real part minus I into imaginary part, where I is equal to square root of minus 1. If d is 0, d greater than 0 has been returned, d less than 0 has been processed here. These are the part of this else block. These are the part of this else block. That means when d is less than 0. Computations are carried out x1, x2, right? Whatever is the case, d is equal to 0, d greater than 0, or d less than 0. Then step 5, what is step 5? What you have to write in step number 5?
Print
Print,
conditions.
yeah, good. Print the roots x1 and x2. Then step 6, we can stop the process. Step 7, if you need, you can write end, just to terminate the algorithm. No more execution will be taken place. This is the simplest level of writing an algorithm to solve the problem quadratic equation ax square plus bx plus c is equal to 0. Clearly write, as we discussed in the first session, these are unambiguous or simply well-defined instructions. Well-defined instructions. That means we need to instruct the compiler, right, what actually needs to be executed. We have clearly right concern when d is less than 0, find a value of square root of minus b. Since D is a negative quantity, minus D is a positive quantity. So that imaginary part is obtained, right? And the imaginary part is right multiplied by I, right? I into imaginary part. That is actually the imaginary part. The real part is separated. Hope you understand, right? Solving this problem, quadratic equation. In case if you have any queries, you can ask. You can also check the problem by providing the sample values A, B, and C, so that you can find the three different nature of roots. Any one of three different nature of roots, real and equal. Roots are real and distinct, and imaginary roots. Have any queries in this example? Ramkumar, Vigneswaran.
No doubt, sir.
Okay, we pass on to the next one. Next problem is the factorial computation. Please take it. I share the slides at the end. Next page. Finding the value of n factorial, or how to find the factorial of the given integer. How to find the factorial of the given integer. Mathematically, we have learned that n factorial, this is the factorial of the non-negative integer n factorial. This is 1 into 2 into 3 into etc. n. This is one equation. And n factorial, this is equal to 1 when n becomes 0. This is another equation because 0 factorial is 1, 1 factorial is 1, 2 factorial is 1 into 2, this is 2, 3 factorial is 1 into 2 into 3, this is 6, 4 factorial is 1 into 2 into 3 into 4, this is 24, 5 factorial is 24 into 5, 120, this way it goes. So the product of first n natural numbers results in the factorial of the given integer only when n is 0, we have the fact, right? 0 factorial as 1. Now the thing is, how do we design the algorithm? Pseudocode we can write it. How do we write in the pseudocode? We can simply state in terms of English-like statements. Input the value of n. If n is 0, print 1. Else, find the product of first n natural numbers. Print the result. Print the value of factorial. That's all. That is the simplest level of designing what one? The pseudocode. Here we do like to represent the algorithm, or we can write the flowchart first. How do we construct the flowchart? I take the next page. Start. This will be drawn in the ellipse symbol. Then read the value of n. input the non-negative integer, right? That means n can be greater than or equal to 0. N must be the integer. Input operation, so it should be drawn in the parallelogram symbol. Flow is small. After reading the value of n, I check logically if I have input either n is 0 or n greater than 0, some positive integer. So here I check the value of n. N I put, right, if you want, right, you put a question mark. So this is a conditional test. In case if n is equal to 0, so we can write explicitly if n is equal to 0. What you can write factorial or simply fact is equal to 1. Draw this in a rectangular box. Fact is equal to 1. Since 0 factorial is 1. Else n should be right having two possible values. It should be right 0 or greater than 0 as the integer. This restriction should be satisfied. So when n is greater than 0, what we have to do? Can anyone explain? How do we find the product of n numbers? Any logic? Or in the simplest level, right? Here I write. In this case, when n is greater than 0, one can write fact is equal to 1 into 2 into 3 into etc. n. Okay, basically let us try to write this one. Fact is equal to 1 into 2 into 3 into etc. n. Flow arrow mark important. N is equal to 0, right? We put, and n greater than 0, we put. Then the fact has been computed, right? Assuming that the product of n numbers are computed, right, in a single statement like that. Next, we are trying to write, right, how to find the actual value of fact by finding the product of n numbers, 1 into 2 into 3 into etc. n, right? I write, right, as the next problem, finding the product of first n natural numbers. Just keep as it is. Fact is equal to 1 into 2 into 3 into etc. n. In this case, fact has been computed, right, based on the value of n. Either n is 0, either n is 0, okay, or n is greater than 0. Next step, we need to print the variable fact. So I write the print operation. This is the print operation. Then we can combine these two facts, right, to join with this print statement. So try to write, construct the flowchart. This line, right, should be same as, right, this beginning. Here also, right, this line should coincide with this vertical line. So assuming that, right, here we have constructed the line, okay, then here print fact. Then we need to stop. That's all. Stop. This is the flow chart to find the value of n factorial. Flow chart to evaluate to find n factorial. Have any queries in this example? Understand the flowchart construction?
Yes, sir.
So algorithm can be easily written. Step 1 start, step 2 input n greater than or equal to 0 integer, right, can be given in the comments or bracket. Then the next line, if n is equal to 0, fact is equal to 1, else fact is equal to this line 1 into 2 into 3 into etc. n. Then print fact stop n. That is the algorithm to find the factorial of the given integer. Now let us try to find this computation alone. Fact is equal to 1 into 2 into 3 into etc. n. This is of course the product of first n natural numbers. Product of first n natural numbers. So let us take the next problem, right? How do we compute this expression? Right hand side of fact is equal to 1 into 2 into 3 into etc. n. I take the next page, please take it. We are drawing or designing the algorithm to find the product of first n natural numbers. First n natural numbers. So the problem is here, given the value of n, assuming that this is the algorithm. What is algorithm? Algorithm is the input-output transformation. We are providing the value of n as a natural number. What is the expected output? 1 into 2 into 3 into etc. into n. This is expected. So the algorithm finds the variable, say product, the variable, okay, product is obtained this way, 1 into 2 into 3 into etc. n. The problem is, how do we find the right hand side, evaluate the right hand side, 1 into 2 into 3 into etc. n. That is a problem. Since the first number is 1 and the last number is n, we can design the iterating logic, right, to find the variable product. So the simple logic first I tell you, please understand carefully. I initialize product is equal to 1. I initialize product is equal to 1. And initialize another variable, for example, I is equal to 1. These variables are necessary. I write how long we need to find the multiplication. I determines the number of times we need to perform the multiplication. Product, right, stores the final result, right, after the multiplication of or after the product of n numbers. First I check whether if I is less than or equal to n. So if when I is less than or equal to n, that I need to write as y. While I is less than or equal to 1, I is less than or equal to n. What we have to find? We need to find product is equal to product into I. Then the variable I is incremented by 1. I is equal to I plus 1. So as long as I less than or equal to n remains true, the variable product gets updated using product is equal to product into I. Then I is incremented by 1. Once I less than or equal to n becomes false, control comes out of this while. Here we need to print the variable product. In this stage, a product holds the product of first n natural numbers. But to see this, first let us check the trace. Suppose for n is equal to 3. When n is equal to 3, initializing I is equal to 1, product is equal to 1. I is set to 1, product is set to 1. While, right, what is the meaning of while? As long as I less than or equal to n remains true, execute these operations. Product is equal to product into I and I is equal to I plus 1. These two statements are executed iteratively until I less than or equal to n remains true. Stated otherwise, when I less than or equal to n becomes false, control comes out of while and it prints the variable product. Now the condition to be tested is I less than or equal to n. I is less than or equal to n. That means 1 less than or equal to 3. Condition is true. In this case, product is equal to product into I. That means current product is 1, I is 1, 1 into 1, 1. 1 is updated into the variable product. Then I is incremented by 1, I is equal to I plus 1 because of this effect. Next value of I becomes 2. Then checking if 2 less than or equal to 3, condition is true. Now product is equal to product into I. Current product is 1. 1 into current value of I is 2. 1 into 2, 2. Then I becomes right 2 plus 1, 3. 3 less than or equal to 3. Condition is true. Now product is updated to current value of product is 2. Current I is 3. 2 into 3. This is equal to 6. Next I becomes 4. 4 less than or equal to 3. Condition is tested. 4 less than or equal to 3. This results in false. So control comes out of the while loop. The next executable instruction is, or simply the next instruction to be executed is print product. Print product is right 6. But actually, right, what is 6? 6 is equal to 3 into 2 into 1 or 1 into 2 into 3. This is the value of 3 factorial. So print 6, that is equal to 3 factorial. 3 factorial, since n is 3, this is actually the value of n factorial. Understand the logic? How we are obtaining the product of first n natural numbers. So this can be written using the flowchart first. I draw the flowchart. 2 initializers are required. Product is 1. I is equal to 1. Next page.
Sir,
Any doubt? Yes.
Sir, we can also use the
Yes.
formula we
Sir,
use
repeat
for
it once again,
factorial,
sir.
right?
Yeah. Using, we can also use the for what you have said.
Can we also use the formula we use for factorial, sir? Factorial.
Yeah, factorial, right? The formula is 1 into 2 into 3 into etc. n, right?
Yes,
But
sir.
the computation, how it is going to be carried out explicitly, right? We are writing the procedure to find the product of n numbers separately. How to find the product of n numbers? Initialize I is equal to 1. The simple logic is start with I is equal to 1. 1 is multiplied with the current product variable. Product variable is also initialized to 1. When I is equal to 1, multiply these two, 1 into 1, 1. Then increment I by 1, I becomes 2. Current I is multiplied with this one, 2 into 1, 2. Then increment I by 3, I by 1, I becomes 3. Current I, 3 is multiplied with the updated product variable. 3 into 2 is equal to 6. This is 3 factorial. This is the logic to find the product of n numbers are simply the value of n factorial explicitly. See one thing, you can also write fact is equal to 1 into 2 into 3 into etc. n here, no problem. But how this operation is actually being carried out, that is actually being carried out like this phrase, starting with IS1 and the product as 1, then checking if I is less than or equal to n, multiply product with I and update a variable product and increment a variable I by 1, continue these operations until I less than or equal to n becomes true. So I draw the flow chart first here, start, so that you will get a clear idea. Start. What are the initializers? Before the initializers, right, we need to input a value n. So don't forget to input n. Input n. The flow is important. Then after inputting n, initialize these two, right, variables. I is 1, product is 1. So just I is 1, product is 1. May be taken as the computational statement. Then check if I is less than or equal to n, conditional box, check box. If I less than or equal to n, this is true. I write the true block here. If I less than or equal to n is true, what we have to do? We need to find product is equal to product into I. In this case, I am writing product is equal to product into I. Then I am incrementing I by 1. I is equal to I plus 1. This one. I is equal to I plus 1. You can write in the next box a rectangular box, or even in the same rectangular box. Sequentially, the operations are going to be executed, whatever is. Okay, I write in the same box to execute these two instructions one by one. Product is equal to product int I is executed first, and then I is incremented by 1. If not, you can draw it in the two rectangular boxes by giving the flow of control. After first flow, right, execution, then give next execution. After the increment of I by 1, again control goes to check if I is less than or equal to n. So carefully listen here. I need to transfer the control without any overlap to this place, because after incrementing a variable I by 1, again we need to check if I is less than or equal to n. If it is true, right, what happens? Product is equal to product into I is executed, then I is incremented by 1. One stage, when the condition becomes false, if I less than or equal to n is false, ultimately here I write, for example, print product. This is the print statement. Or you can write the print right in the next line by giving a vertical mark here. Because of space, I have written in the same arrow line false print product. Then to end the process, here put stop operation. This is the flow chart to find the product of n numbers. To understand further, right, I try to do the trace for some another number. For example, let me take n is equal to 5. When n is equal to 5, look here how we are tracing this flow chart. N is equal to 5, one time input is given. The variables required are I and the product. So I try to construct a column I. Here this is product. What are the initial values of I and the product? I is 1, product is 1, one time initialization. So I write, this is a column heading, I is 1, product is 1. Then checking the condition if I less than or equal to n is true. This is the conditional test. So I write here I less than or equal to n. What is current I? Current I is 1, 1 less than or equal to 5. Condition is true. I put a tick mark, right? To have the condition is true. I less than or equal to n, condition is true. Then what are to be executed? What are the statements to be executed? Product gets updated. Product gets updated as product is equal to product into I. So here I write updated value of product because product column has already been returned. Okay. Product is equal to product into I. I am executing this instruction. Product is equal to product into I. With respect to the same product column, product is 1 into I is 1. 1 into 1 is equal to 1. This 1 is stored in the same variable product. Please understand. The expression product is equal to product into I evaluates product into I and result is again updated in the variable product. So this column right product, this indicates the value 1 is currently assigned into the variable product. Then I is equal to I plus 1. Executing this instruction, I is equal to I plus 1 means current I is 1, 1 plus 1. 2 is actually being updated in the variable I. Hope you understand. After this, control goes to check if, see here, control goes to check if I is less than or equal to n. Conditional test. Now I less than or equal to n means current I is 2, 2 less than or equal to 5, condition is true. If the condition is true, product is updated, product, right, current value 1, this is multiplied with current I is 2, 1 into 2 is equal to 2. This 2 is actually being stored in the variable product. Then I is incremented by 1, I becomes 2 plus 1 is equal to 3. After this increment, I is equal to 1, I is equal to I plus 1. Check if I less than or equal to n is true. So here the new value 3 less than or equal to 5 condition is true. Then update the value of product. This 2 is multiplied with this 3. 2 into 3, 6. Then I is updated 3 plus 1, 4. Then next 4 less than or equal to 5. Condition is true. Update current product into current I. 6 into 4, 24. This is 24. Okay. Now I is updated to 4 plus 1, 5. 5 less than or equal to 5 condition is true. Next, here 24 is the current product. This is multiplied with product multiplied with current I. Current I is 5. 24 into this I, right? 5 results in 120. Then I is incremented by 1. 5 plus 1 is equal to 6. This stage current I is 6. Next, checking if 6 less than or equal to 5, proceed mark, condition results in false. So when the condition becomes false, the next executable statement is this one. False means print product. Sorry, here print product. When I less than or equal to n becomes false, the next executable statement is print product. Here, 6 less than or equal to 5, current I is 6, n is 5, 6 less than or equal to 5, condition is false. So, next executable statement is print product. What is the current product? This is the updated value of variable product. Product currently holds the value 120. So print 120. But actually what is 120? 120 is 1 into 2 into 3 into 4 into 5. That means this is the value 5 factorial. That means the product of first n natural numbers are multiplied and the result is printed in this flow diagram or in this diagrammatic representation. So here we can write this is the flow chart figure. Flow chart to find the product of n numbers 1 into 2 into 3 into etc. n. Or you can write the flow chart to find the value of n factorial when n is greater than 0 and integer. Because here we didn't check for n is equal to 0. So when n is greater than 0, suppose n is equal to 7, 8, right? 7 factorial, 8 factorial, right? These values are computed using this flowchart representation. So how do we write the algorithm? Algorithm, right? We can write step 1, product is step 1 start, step 2, input n, step 3, product is 1, step 4, I is equal to 1, step 5, while I less than or equal to n, we can find the computation. Product is equal to product into I is equal to I plus 1. Then in the next step, print product, stop n. This is the algorithm, right, to find the product of first n natural numbers are simply algorithm to find the product of, algorithm to find the value of n factorial. Have any queries? Any queries? Please ask me. Have any doubts? So in this session, we have focused on these things, right? What is the quadratic equation and what are the nature of roots for the given quadratic equation? Three nature of roots are identified. We have computed the calculations for the three nature of roots. Flowchart is represented, and we have drawn the equivalent, right? A flowchart, and the flowchart to algorithm has been designed. Then we have solved this problem, factorial problem. Factorial is computed as, right, using the equations 1 and 2, flowchart that we have written, and the algorithm to find the product of first and natural numbers. That means algorithm to find the value of n factorial has been written, right? The flowchart has been written. We have checked the flowchart to check if it is working, to check if it is working correct or not for all possible values of n. That is, this is the trace. We have ensured the correctness of the algorithm, correctness of the flowchart, so that if we input n is equal to I, 120 is the result. Putting n is equal to 6, 6 into 120, 720 is the result. So whatever the value of n, this flowchart clearly computes the value of n factorial, assuming n is greater than 0 and n is an integer. No queries? Any doubt?
No doubt, sir.
Okay, thank you very
No
much.
doubt, sir.
Right, please go through
Thank
the
you, sir.
session. I post the material, and yeah, I post the material after some time. Once again, go through the session, and if you have any queries, right, you ask me. We will discuss tomorrow. Thank you very much. Prepare well.
Thank you, sir.
Thank you, sir. Thank you, sir.